Assalamualaikum warahmatullahi wabarakatuh. My name is Rullif Marcelino from Design and Manufaktur Engineering. In here, I will describe my last project with title Design and Manufacturing of three-wheel minimalist prototype scooter handling system for logistics. Support the fast power facility with 200 kilogram capacity. With my first supervisor lecture is Mr. Priyambo Donut Adinugo, and the second supervisor lecture is Sri Andi Setiawan. In here, I will describe first preliminary to methodology, three result, for conclusion and suggestion. The background of the problem for this research is the transportation is highly demanded by the people and especially for the entrepreneurship for logistics support. But for small, micro, and middle entrepreneurship, that the three-wheeled motorbike is very expensive and the price of commercial three-wheeled motorbike is less affordable. Also, after that, many people modify their own motorcycle in order to carry more goods without calculation. And this effect, in the other hand, the modified vehicle is unsafe and endanger other driver and carries a risk of injury. Also, the problem is to this research is how to design and build a steering system and driver seat and on an ergonomic three-wheeled scooter. The second is how to design and manufacture a braking system on a three-cycle scooter. And three, how to calculate and analyze the braking distance of a three-wheeled scooter. In here, the purpose of this research is able to design and manufacture a steering system and driver seat on a ergonomic three-wheeled scooter, and two, able to design and manufacture a braking system on three-wheeled scooter, and three, can compare theoretical and actual braking distance values. And this is the research limit. The first is the maximum capacity scooter is can carry 200 kg with driver load 90 kg. And number two is the research only plans the steering system, braking system, and driver seats. The three, steering system and driver seats were analyzed using CATIA software with the Rullif or Rapid Upper Lane Assessment method. Fourth, design of the braking system is only up to the calculation of the braking force requirement, driving the braking system, and manufacturing the brake caliper braking. And the scooter test is assumed to run on flat, not bumpy asphalt or and dry surface. And the design is only carried on three-wheeled scooter. The method is the first in here and identification problem and consumer needs, and second is concept creating, and after that the concept is analyzed by FM and Rullif method. After that, concept is being selected, and after concept selected, we calculating the braking force need. After that, the process of manufacturing. After manufacturing is trial, and the result of trial will get a conclusion and suggestion. There is three concept is created in here. With the first concept is here with the red color. This is the handlebar and the seat frame, and also the second concept with here with red color. Third concept also with red color, and this is the dimension of the handle, seat frame also for second concept and third concept. All of the concept is used as TMA53 with material with outside diameter of 33.4 millimeters with thickness 3.38 millimeters, so that cross-sectional modulus of 2176.42 millimeters cubic is known. And for the handlebar, material used SGH40 with diameters 22 millimeters and 2 millimeters thickness. The first concept in here we can know from manual calculation with result is 31.76 megapascal, and calculation of software is 32.95 megapascal. The value of the stress does not exceed the permit stress is 60 megapascal, so the design is safe. And the ruler or ergonomic simulation is to show the value is 2 according to the ruler worksheet is safe and can be continued. The second concept also with manual calculation is 8.45 megapascal and the software calculation is 5.87 megapascal. So also the stress does not exceed the permitted stress, namely 60 megapascal, so that design is safe. Also in here, the ergonomic analysis show a value of 2. According to ruler worksheet, the concept is safe and can be continued. In third concept in here, the manual calculation result 20.28 megapascal. In software in 20.18 megapascal. This is also does not exceed of 60 megapascal, so the design is safe. Also, the ergonomic analysis has also a value of 2. According to the rural worksheet, the concept is safe and can be continued. In here is the concept chosen based on the selection table. Concept 2 was chosen to be developed and made for a minimal scooter because it has more value than other concepts based on the aspect and criteria. In here we can see the first category is can handle driver load. The second concept it has lowest stress. In here is and the manufacturing cost is also easy and low in Tugas. It's also easy to manufacture. So the second concept is chosen. This is the reason why the second concept is chosen. This is the process of working. We can see the handling system, manufacturing process, and braking mechanism assembly. And third is scooter finishing process until the manufacturing process finished. In the braking of needs or braking force, we can know that scooter braking force need to stop from 80 km per hour is 116 newton or 215 kilograms. Braking force produced its disc brake is 84 kilograms and its drum is 29 kilograms. And the concept is C with full disc brake is produced 2,473 newtons or 252 kilograms. According from the table above, the scooter braking is used full disc brake system. And the trial is we know that the distance with actual is 2.7 in 25 km per hour. In 30 km per hour, it results 4.3 meters, and 35 km per hour is 0.5 meters. From the table is scooter trial is know that braking distance is not exceeding the SNE maximum distance limit. Based SNE 1896 in 2008, scooter braking system is acceptable and fulfill the security. In here, the trial scooter is loaded with 200 kilograms for braking distance trial. And the conclusion in first is making a handling system using Fusion 360 and KTV5R18 software for the ergonomic simulation process. The frame dimension is here 500 times 250 times 440 with STM-A53 with material ISM and software analysis result is 5.87 MPa. Manual is 8.5 megapascal with load of 90 km. Idle bar with dimension 610 times 110 times 300 using SGH 40 diameter 22. The ergonomic simulation result gets score 2. The making of the chair frame is done by cutting, welding, grinding, and paint. And the second braking use the entire disc brake. The required braking force is 2,216 Newton The resulting brake force is 2,473 newtons, and 3 manufacturing include drilling, cutting, and welding. And the braking of the scooter is acceptable and met comply SNE 1896-2008. And here the video of scooter braking trial.
Dua 2,7 meter. Empat 4,2 meter. Yo. Pas dulu nih. 5 meter.
And the last but not least is the suggestion for the next research is first is replacement of the seat frame and steering handlebars with lighter material but stronger. And second is the analysis of braking with many variations in load and speed parameters so that the detailed braking value can be known. And thank you. Terima kasih kepada semuanya. Thank you for your attention. If there is a wrong words and I apologize. Assalamualaikum warahmatullahi wabarakatuh.